Hello everybody, welcome to Simplified in 5. Today we are going to talk about software defined networking. So let's first see how things were before SDN came into picture. So let's see, consider this as a simple portion in a big network where you are using an application through a PC or mobile, and it has, let's say, four switches: S1, S2, S3 and S4. And it's a very common scenario that one of the paths in network, like path 2 here, gets congested, and the traffic from your PC or mobile towards the application server gets very slow. This is a very common scenario, and in such cases the network engineer has to troubleshoot and find out the reason uh, for this congestion, and either divert the traffic through path 1 so that the uh, traffic is equally distributed amongst paths, and user gets the proper speed for the application. Similarly, SDN control with SDN controller in picture, network engineer will have less to do, and he can focus more on the engineering side of it instead of troubleshooting. So SDN controller will sit in between the network and have an eye on the switches as well as the paths in the network, and it will look at the network with an open eye, and it can see if there is a congestion in any path, and it will control the traffic accordingly. So with SDN control, you will have less scenario of network congestion between PC or mobile and the application server. So let's first see how SDN works. So SDN controller basically sits between the human interface and the network devices like switches, routers, load balancers, and firewalls. And SDN controller talks to all of them. And through human interface, you can operate on the SDN controller and indirectly control the network devices. So what is SDN? SDN, as we know, is a software defined networking, and it's an architecture, and it's not a product or protocol. You use it for designing the network management. It acts like a middleman, as we just saw, and it translates the human wishes into machine commands. It separates the command and control from the data which flows in the network. So networking devices should only carry the data. Don't have to make the decisions for related to data. The SDN controller will make the decisions, that is command and control will be with SDN controller, and which in turn will be with the human interface that sits on top of SDN controller. And SDN controller could be physical or virtual or combination of both. So advantages of SDN is it's some of the very obvious advantages, like it provides the much needed real-time network omniscience. And that's why basically it was invented that you need to, if your network is growing bigger and bigger, you need to know a lot of things at the same time. So SDN provides you the uh, network omniscience that is needed to handle large networks. Obviously it reduces the human effort spent in monitoring traffic and finding bottlenecks and fitting in new things. Like if you want to grow your network, then also SDN control could be of very much help. It reduces the racking and stacking time for hardware, cables, and other networking devices. It definitely brings the consistency amongst multiple devices, and a no-brainer, like it reduces manual errors through the automation. Uh, so looking at the advantages of SDN, it's a very lucrative technology, but you should give a proper thought and see when you should not go for it. Uh, let's say if do due diligence and see if the return on investment uh, is not matching your expectation, considering the cost of SDN technology, then maybe you should not go for it. If your organization already has a lot of virtualization, and if you have a less physical networking devices, then maybe SDN is not the correct thing to do in first place. So Also, if your organization is small, is having small network, is having less complex connective WAN connectivity, then maybe SDN is not needed right away. Similarly, and one of the examples is organizations with limited geographical footprints or having lot of virtualization should go for NFV first, which is network function virtualization, and then the SDN should be used. Now let's see the use cases. That is when you should go for it. So if you are having many physical networking devices, then yes, you should go for it. If you uh, have need to handle sudden extensive changes to the network traffic, if you are not using much of virtualization, uh, if you have a complex WAN configuration, then definitely you should go for SDN. So one of the examples is like if your organization is providing training environment, or if you are using DevOps for change management, where you have to react to sudden network changes or bring content online urgently, then SDN is the way to go. So basically, these are the five key things to know about SDN. So when you should go for it, when you should not go for it, what are the advantages, what is SDN, and how does it work. So thanks for watching and hope this helps.